thank you so much, Monica and Denise, for setting all this up. It was a great day yesterday. I'm in the unenviable position of first speaker Saturday morning, so I'll see if I can't keep things a little bit lively. I'm Greg Lynn. The kind of message is, like the message from The Graduate to Dustin Hoffman, that the future is plastics. I've been very interested in plastics, not so much as a material, but as an approach to assembly and composition. And I thought I'd run through a few things, but I thought I'd first start with an example of a facade by Tectonic outside of Turin. What's interesting to me about this example of kind of transitional Baroque Rococo architecture is, first of all, that it's very curvaceous, but primarily that all of the elements of the facade have been integrated into a language of surfaces. So cornices, pilasters, archways, all of it is occupying a surface plane or a series of surfaces, not layered surfaces, but is really thought of as a kind of a skin. And progressively, I think design in general has moved towards a language of surfaces. I know in the car industry, Chris Bangle's very specific about cars were little houses like carriages, and they became boats, and then they became planes, and now they're really thought of as surfaces in terms of their vocabulary. So plastic surfaces, like for example, this foam cut wall that then gets skinned in resin with chopped fiber and recut, or vacuform panels with integrated printing and color and texture, or even plaster surfaces that get faceted and folded. It's a language of surfaces, and it's a language of spatial plasticity, meaning continuity and change. One of the things that this does to design when you start thinking in surfaces is you start integrating what were previously disparate elements. So for this tableware set, the elements of the tabletop get integrated into a single surface while still retaining their unique parts. For this chair, not only the bucket, which would have been a seat and a back and arms, gets integrated into a soft surface, but also the legs and base gets integrated into a surface. So this logic of taking parts and pieces and assembling them into something which retains its components while still being whole is, to me, the language of plastics. And it's also a language of synthesis and proportion and resolution, where you have similar parts put into an array or a composition of elements which are put into relation with each other. It raises a lot of questions of symmetry and proportion and harmony in terms of composition, not just materials. These are some plastic pavilions we're doing for the Index Awards in 2 years. And the other thing about plastics is it turns out to be a very lightweight, easily manufactured. I mean, it doesn't have that much embedded energy in it in a lot of cases, inexpensive construction material. So for the Index Awards, they have roughly 80 objects from the scale of a car to, say, a drinking straw that they exhibit, and they exhibit it at 4 or 5 venues. So not only the objects have to get put into containers and shipped around by boat and truck, but the pavilions that contain these things have to. So we invented a kind of flat pack system with 3 different kinds of plastic, Lexan panel with a custom kind of zipper connection, so that 2 people can erect one of these pavilions in an afternoon, and we can fit 9 of these pavilions into a single shipping container to move it around. And you'll see there are 4 colors of material we're using. The black plastic has photovoltaic in it. The clear is obviously clear, then there's a mirror finish and a dichroic finish, and all the objects exist inside these pavilions, and the pavilions make a little kind of village or street when you put them together, but they're also completely off the grid, because the big headache with these venues is trying to get power to the pavilions that are outdoors. So the photovoltaics generate the power and store it in batteries and then run the lighting and computers inside the pavilions. Okay, so autobiographical interlude. I've always loved boats, sailboats, not just because I like to sail, but also because of the construction. And also, when I was a kid, my father worked for Container Corporation and was responsible for the invention of blister packaging, which is, melting plastic over small parts and onto a cardboard backer. So I was always interested in sailing and plastic, although I got this very mixed message as a kid because we had these old wooden boats. And I would spend my summers on Lake Erie in Ohio for the first 2 weeks stripping down and sanding a wood-hulled boat and varnishing it. It was an incredible amount of work, but it was also very interesting because the boat was built like you would have built a house 100 years ago. It had ribs and framing and planking, and the planks were screwed to the frame. And it was assembled out of parts, and those parts were put into a relation of kind of doweled and mechanically attached parts. And that's what I would call a tectonic paradigm. It's how you put pieces together and make something large out of small parts, and how you put parts in relation to a whole. Now, a plastic paradigm, and by the way, I was always looking down my nose at plastic boats. I mean, we called fiberglass boats plastic boats back then. And by the way, this, is my plastic boat, which for me is not plastic enough because it's heavy. So the plastic paradigm is very different than the tectonic one. Working with a carbon fiber or aramid fiber or glass fiber reinforced shell, you can take all kinds of stuff, balsa wood, cardboard, aluminum, titanium, fiber. You put it all into a bag, and you put that bag under vacuum pressure and cook it, and you assemble all the parts with glue. And all the parts are oriented and distributed for strength and aesthetics and form based on lamination and gluing. So it's very different than the tectonic paradigm, where you have a frame and you have a cladding and you have an interior surface and you have all these layers. In this case, you don't have layers. You have a matrix that everything flows in and gets put into a bag and cooked together. So that paradigm of putting things in a bag, where the bag has an inner and an outer surface, but putting things in a bag and cooking them, it's a very different approach to assembly and construction. So here's the tectonic paradigm, a drawing by Semper, where all of the elements of the envelope are separated and layered, one on top of another. And what's so ironic about today is there's more tectonic layering going on in architecture, not really in design, but in architecture than ever before. Like, sometimes you'll see 4 or 5 layers of facades on a project. It's a very antiquated way of thinking about construction, despite the fact that in a lot of cases those things are all plastics. This is an example of how a boat used to be built, where you can see the kind of keel like a beam and the framing and stringers. This is an example of how you build a boat today. It's, that's a single cooked structure with bulkheads and framing and carbon reinforcement and glass skin, all put in a vacuum and cooked, sometimes even under several atmospheres of pressure if you autoclave it. And the effect on things is that you start to lose the fetishization of connections and details. Now, I know this is probably beyond everyone's interest, but you can see in the rig all of the composite fibers and composite structure means you don't have all kinds of turnbuckles and methods of attachment everywhere. Things are really, connections and joints are integrated and synthesized, and elements really begin to behave like a single continuous object rather than a whole series of parts and pieces. The way that that starts to affect the way you think about surfaces and structure is that you can still have layers of construction. You don't literally have to build in plastics, but the surface really begins to take more precedent as an organizing element. I think to go into interiors and things, this is an image of a chapel at the crematoria of Ostland at Woodlawn Cemetery, which I've always liked. It's a piece of bent plywood, but instead of being a piece of furniture in the space, the wall of the chapel folds out and becomes the bench, and that surface ends up becoming the furniture and seating. So in the spirit of taking disparate elements and fusing them through a language of surfaces, these are some images of a private house in Los Angeles we just finished, where the idea was to make not an open plan space where you would have unarticulated free space, but also not to make rooms, but to take the surfaces of the walls and fold and mold them to start to divide the space up. So you can see the fireplaces, the shelving, the powder room beyond, all gets sucked and bagged, let's say, into a single plaster surface. The bathrooms also take all of the equipment of the bathroom and pull those into these surfaces that get molded and shaped. I'll show you some images of how that was done. But you can see in the kind of main living floor plan that there really aren't rooms. What there are is pockets and folds of the two lateral walls that absorb all the individual spaces. And then upstairs, there's a similar wall that absorbs all the bookshelves and bathrooms and beds and things like that. There's a big luminous ceiling also that's kind of like the size of a J-80 boat or something, just stuck to the ceiling. It was built by a boat builder. And then all of the windows on the lateral facades all pinch into a single line. So the way that we built this, in terms of economies of construction, the plaster surfaces were all cut from plywood with a laser cutter. And I asked this person that runs the laser cutter how long had they been cutting it, and they said, well, they've had it for about 30 years. So it was amazing to me that it took 30 years for somebody to cut framing. It also turned out to be very efficient, much more efficient than buying stock lumber and cutting it and framing it. We could pack all the components onto sheets with very little waste, and snapped it together in about 45 minutes. 2 people from my office and the contractor went over when it got delivered, and we were forbidden to play with this stuff because it was all numbered and they were afraid it would get out of order. But so basically 4 amateurs could pop these walls together. The experts came in, and this is a plasterer that's been working for like 50 years. We had to find who could do good plaster work over these elements. But so there wasn't a lot of people banging together things with hammers. It either fit together because it came off a machine, or there were artisans that built it cleanly. With the windows, these are just stock Pella windows. They call them cathedral windows, where you get a kind of curved sash. And we just flipped it over so that we could get these kind of pinched eyeglass windows. And then for the luminous ceiling, we cut foam molds with a guy, Bill Chrysler, up in Sonoma, who we've been working with for years. And this is a mill that Bill built himself 15 years ago with ropes and pulleys. He didn't even know there were industrial mills at that point. And we would cut the foam. Well, Bill would cut the foam, cover it in aluminum foil, and then we cast it into these panels that then all come together and has a cold cathode tube running down the middle of it. The bathrooms were molded and 3D printed in the office. And then we worked with DuPont very closely to come up with an economical way of molding these Corian panels and bonding them together for most of the built-in furniture. So all the sinks and everything are stock, and then the forms are custom. Even the bed we did with the bamboo flooring. Since all this, I've actually had the pleasure to start designing boats with Tim Kernan and Fred Corabla. This is a catamaran, but a lot of the logic of folded surfaces and apertures and things are now coming into the boat construction projects, and we're also doing a sloop. It's funny, they never build models in the naval architecture field. But a lot of the language of this stuff comes out of the studies and physical models, which we could do in the office using the same equipment we actually build with, meaning laser cutters and mills. This is a sloop, 44-foot cruising sloop. Some of the construction photos of it. Okay, so also one last thing I'd say is that the collaboration with other fields has really changed the way I think about media and content and narrative. I'm not going to go into a whole lot of it other than to say that on most building projects I'll work with imaginary forces to integrate content into the buildings, and there's been a kind of reciprocal thing where now for certain films and television shows we're starting to do a lot of conceptual work. So we're designing this alien for a new television show called EX. What's funny is it came out of a visit to those Vitone churches in northern Italy, the idea for this, the form of this alien. And right after that, we were asked to do a lamp for the SIGGRAPH event this year. And so this is St. Chiara, which is a very perforated out and kind of skeletalized dome. And so we did this lantern called the Sciarra Dome, again with this guy Bill Chrysler, where we made a mold and then divided the mold up into fiber reinforced concrete panels and fiberglass panels. And that's it in New Orleans. Okay, and finally, if I could play this one movie. I did this thing I'm going to show you called the Blob Wall, and a friend of mine was shooting a low-budget movie and needed some models of proposed casinos, and grabbed the first prototype of the Blob Wall and used it in this movie, The Grand. And I thought this would be a good thing to kind of wake everybody up.
I like this one too. It's called Hector's Frozen Cart. Now I'm going to be candid with you and let you know that I don't know what I was thinking when I came up with this particular design, but I was under the influence of cocaine and heroin and marijuana and LSD and mushrooms and some ecstasy. And you know how sometimes you get that cocktail just right and then there's just a boom.
So anyway, it's a very funny movie. You could TiVo it now. It's called The Grand. And he improvised all that. But so for the blob wall, I was designing an interior wall for my own house, and my wife Sylvia Lavin grew up in Rome, and so loves any kind of orange or red plastic object. And I was sitting around the house, and I realized I was with two little, at the time with two kids that were kind of, 4 and 6 years old. My life was surrounded with these big plastic toys, like rocking horses and play structures, and just everything was a big hollow plastic rotomolded object. And I'd been watching what Monica and Nadir were doing with bricks, and I thought, I don't have a language of masonry and construction in terms of masonry. I should be thinking about this, like what would I think about in terms of brick and stone? And so I had this idea of treating hollow plastic toys as bricks. And what I found is that I couldn't get enough toys to, I needed like several thousand toys to make a wall. and it turned out to be more difficult to get recycled toys than I thought. And anyway, I had a model of this recycled wall sitting in the office, and a friend, Andreas Frosch, who's worked with me for, I don't know, almost 20 years, we've worked together in one way or another, saw it and said, "What's that?" And I said, "Hollow plastic toys cut into bricks." And he said, "Well, this is something Panelite should be doing." So we invented this brick, which has 3 lobes, just so that it'll nest with itself and create texture. And we array those bricks in along different surfaces and find where the bricks intersect each other. And we take those points of intersection, which are paths, and send it to a robot. Andreas does this in his factory. And the robot will cut the path where the 2 bricks intersect, and then you take those cut bricks and stack them together. The pieces you cut off, you just throw back in, you chop them up and throw them back in the rotomolder. So we can also get every brick a little bit different color. So they're dappled and textured. And all these bricks interlock with each other and get welded up and become very rigid in terms of construction. And SciArc asked me to do an exhibition. We kind of thought like what shape to do, so we just made a giant brick. And students worked like crazy there's a lot of labor involved in putting these things together. And then Aaron Betsky asked for the Venice Biennale if I would do something with the blob wall, and then at the last minute he said he'd been bored with the blob wall, so I needed to do something different. So I went back to the toys and grabbed some of my kids' toys and went on eBay and got all the toys I could get, got several hundred, scanned them all, put them into the computer and, composed them, and then, cut them up and started to develop furniture out of these recycled toys. So a shelf, the dog shelf, and a kind of low whale table. And now for the Hammer Museum, we're taking these things and doing now kind of Baroque fountains. So there's Bernini's. Triton's fountain. So this is one of those fountains that we're doing with a combination of blob wall bricks at the base and then arrays of toys to make the figure, and all the ducks and sharks spout water, and it all fills in a pool. And then there's another one that's a little bit larger. There. Thanks.